So our problem is find the work done performed by the force field F is equal to x square I plus 4xy cube j plus z square k on the particle that traverses the rectangle C in the plane z equal to y shown in the figure. Here the figure is given like this. You can see this is x-axis towards us, this is x-axis, this is y-axis and this is z-axis. And this is the curve, this rectangle is the curve or this rectangle is given by the plane z is equal to y, that is shown in the figure. And see, the curve is the boundary of the rectangle. And what is the direction of this? Obviously you can see it is in the, as the direction is given like this, it is in the clockwise direction. So we have to identify the direction from the direction given in the figure itself. So you are asked to find the work done. And already I told you that in this vector calculus, work done is calculated using Green's theorem for the two variable cases. If the function f is of two variable, you can find work done using Green's theorem that we already seen. Now here the function f is given in three variables, isn't it? X, y and z. And you are asked to find the work done. And you know that work done is integral over C f dot dr. So the divergence theorem itself, the Stokes theorem itself gives you the work done. That is integral over C f dot dr, which is equal to double integral over sigma curl f dot dn ds. And we are using this formula for evaluating, that is double integral over the region curl f dot del g dA. Now we will find out one by one. Then curl f, as you know, that is determinant I j k dou by dou x dou by dou y dou by dou z, then x square 4xy cube and z square x. So it is equal to I into dou by dou y of z square x 0, dou by dou z of 4xy cube is 0, minus j into dou by dou x of z square x is z square, minus dou by dou z of x square is 0, plus k into dou by dou x of 4xy cube is 4y cube, minus dou by dou y of x square is 0. So what you get here is minus z square j plus 4y cube k as the curl f. Now let us find out curl f. We have obtained the del g, and we know that del g is equal to I dou g by dou x plus j dou g by dou y plus k dou g by dou z. So here you should know what is g represented as. And what is given the surface is the plane z is equal to y. And how we take g is depending upon the direction. If it is in the clockwise direction, we have also seen that it is in the negative orientation or negative z direction. We are taking the normal to the curve. So we are taking, in order to get a negative z value or negative orientation or a counterclockwise orientation, we should take g is equal to y minus z. Okay, you know that we are already denoting z as gxy, and either we can take z minus g of xy or g of xy minus z. In both ways we can represent g. But why we are taking here as g of xy minus z is because the direction is given as negatively oriented or in the negative z direction or the clockwise direction. So that is why we are taking g is equal to g of xy minus z. G of xy is y here, right hand side of this, and y minus z. So let us take g is equal to y minus z, so that I into dou g by dou x is 0 plus j into dou g by dou y is 1 plus k into dou g by dou z minus 1. So you can see that z has a negative z values there. So it's given by j minus k. So we have obtained both del g and curl f. Okay. Now we will substitute it over here. Curl f and del g Therefore, work done is equal to double integral over sigma curl f is minus z square j plus 4y cube k dot del g curl f dot del g is g minus k then dA. So over the area we are calculating it as over A. Now it is equal to double integral over the region A minus z square j, so it will get obtained as minus z square plus minus into 4y cube dot product. Now dA is either dx dy or dy dx, that we take according to the figure. Now what you have to identify is the limit of x and y. Now you need not have to draw anything or the image of here. You can here itself in the figure itself you can see the image is a rectangle in the xy plane and whose coordinate here clearly given. Along the y here it is given that it is 3. Along the range, along the x-axis it is given 1. So here you need not have to evaluate any other thing on depending on the range. You can just take x varies from 0 to 1 this side of the rectangle and y varies from 0 to 3. So the variation of x is from 0 to 1, y varies from 0 to 3. You can see that is given in the figure itself. So it is equal to double integral. X variation is 0 to 1, then y varies from 0 to 3. Then minus z square, you can see that here we are evaluating with respect to x and y. So you need to change this z in terms of x or y. How? The plane itself here it is given as z is equal to y. So we can substitute z is equal to y. Therefore z is equal to y. So it will become minus y square minus 4y cube into dy. If the first integral is with respect to y, then dx. Either you can take either of them, either dy dx or dx dy according to the limit given. So integral 0 to 1, then integral 0 to 3, let us integrate this, minus y cube by 3 minus 4y raised to 4 by 4 dx. So then we have x is equal to integral 0 to 1 minus y cube by 3, the limit is 0 to 3. So taking the limit 27 minus 27 by 3 minus 4 into y raised to 4, that is 81 by 4 and 4 cancel, so it is 81 dx, isn't it? The lower limit is 0, so you will get 27 by 3, that is equal to integral 0 to 1, 27 by 3 is minus 9 minus 81 into dx. So it's integral 0 to 1 minus 90 dx. So again evaluating, it becomes minus 90 into integral with respect to x 0 to 1. So it is equal to minus 90 into 1 minus 0. Hence the final answer is equal to minus 90. So here there is not much confusing part. You can just go to the plain form, either z minus y or y minus z. That depends upon the direction, which is in the clockwise direction. We take y minus z, negatively oriented, and then we find out curl f and then del g and substitute there, and the limit is directly obtained from the figure itself, 0 to 1 and 0 to 3. Substitute and evaluate. Okay, thank you.